Post-surgical and irregular corneas challenge even the most experienced fitters, from post-RK and grafted corneas to PMD and LASIK ectasia. These are eyes that break the rules. So, we design lenses that break the mold. Maxim 3D is built for this. With free-form back surface control, every zone of the lens can be tailored to match the most complex corneal shapes. That means precision alignment, stable optics, and comfortable wear, even on the most irregular eyes. Start the same way you would on any scleral fit, by selecting the correct diameter. From there, choosing a trial lens gets trickier. On irregular eyes, the highest point of elevation might not be central. Your goal is to find the lens in the set that clears that highest point and contours best to the peripheral cornea. Once the trial lens is on, the real fitting work begins. Let's say the peripheral fit looks good, but the central clearance is excessive. Flattening the base curve reduces central sag, bringing the lens closer to the cornea. This adjustment transforms a standard prolate design into an oblate shape, without trialing multiple lenses or changing the landing zone. Zone-specific changes are key on these eyes. Take a classic PMD case. You might see excessive vault at the top of the optic zone, but just barely clear the cornea at the bottom. Since the optic zone must remain spherical for vision quality, we aim for about 100 microns of clearance over the closest point. From there, you can steepen the zone directly below the optic to contour that inferior cornea. Then recontour outward to redistribute weight and improve the landing. This adjustment reduces tight inferior landing, improves comfort, and minimizes decentration from saline pooling. Let's run through a few common case types. Post-RK, these eyes have flattened central zones with steep mid-peripheral ridges. Flatten the base curve to reduce central sag and steepen the mid-periphery to lift the optic edge and avoid bearing. Post-PK, graft-host junctions often cause mid-peripheral clearance issues. You can specify exactly how many microns you'd like to steepen the mid-periphery for a better match. Then, flatten the base curve by the same amount to maintain central clearance. Each graft is unique, so partner with the consultation team when needed. PMD and inferior ectasia. Use a flatter base curve to avoid excess sag. Then steepen the inferior zones to follow the ectatic slope and recontour the landing to reduce inferior compression and improve centration. Post-LASIK, standard fits usually work well. If ectasia is present, fall back on the principles we just covered, identify the high point, align the zones, and design with intention. Now, rotation matters. Once the lens settles, gently rotate it about 30 degrees. If it returns to the same position within a few blinks, you've got a stable landing. It may not rotate to where the star was expected, but if it's consistent, that's what matters. Document where the star lands. This gives the consultation team a guide to how the lens aligns rotationally, especially if doing zone-specific changes or if front surface optics will be needed. With Maxim 3D, you're in full control, zone by zone, micron by micron. No matter how irregular the shape, the goal remains the same: healthy alignment, stable optics, and all-day comfort.